Hello there, welcome to math video number 21. What are we learning about today? We're learning SOL 4.15. The student will recognize, create, and extend numerical and geometric patterns. Please note that this topic is not covered in Math Ed. So it's really important that you take some time with this and make sure you fully understand this concept because you have not learned about it in your Math Plus Red course. So there are two types of patterns. You have number patterns and geometric patterns. And we're going to be looking at both of those today. Now within each type, there are repeating patterns, increasing patterns, or decreasing patterns. So let's look at this. So when you are working with numbers, a repeating pattern would look like this. 1, 2, 3, 1, 2, 3, 1, 2, 3. It's just the same thing repeating over and over. An increasing pattern is when you're either going to be adding or multiplying numbers in order to increase the numbers. So you're either going to add or multiply to get your increasing pattern. So you can see here it goes from 1, 7, 10, 1, 4, 7, 10, 13. It just keeps getting bigger and bigger and bigger. And then you have to try to determine, okay, why is that getting bigger? What's happening? I'm going from 1 to 4. So I'm either multiplying times 4 or adding 3. 1 plus 4, or 1 plus 3 is 4. 4 plus 3 is 7. Okay, that seems to work. 7 plus 3 is 10. All right, I bet that's the pattern. 10 plus 3 is 13. Yeah. So you're increasing by adding 3 each time. And we call that the rule. That's the rule for this pattern. Now, a decreasing pattern is when the numbers might start with big numbers and then they just keep getting smaller and smaller and smaller and smaller. Okay? And for those kind of patterns, you're either going to be subtracting or you're going to be dividing something for your rule. So let's look at the one that we see here. So we start with 72 and we get to 63. Okay, well that's a difference of 9. And then from 63 to 54, that's a difference of 9. Okay, so actually I could either say I'm subtracting 9 or I'm dividing 9. No, you could not say you're dividing 9. Sorry. Because if I said 72 divided by 9, I would get 8. Boy, that would be a big jump. So, no, I was incorrect on that. The rule is you're just subtracting 9. Okay. So that's what you need to look at. You kind of have to be a little bit of detective and just look really carefully at what you're seeing and try to determine, first of all, is it repeating? Is it increasing? Is it decreasing? And what are they doing? What's the rule that's causing this pattern? Okay, so you also have geometric patterns, and those are with shapes. So a repeating pattern would look like this. Square, circle, square, circle, square, circle, square. You know, it just goes over and over and over and over. The same thing over and over. And an increasing pattern is something like this, where there's 1 circle, and then 2 circles, and then 3 circles, then 4 circles, then 5 circles. Can you guess what would be next? 6 circles. So that's a typical question. They'll ask you, what would be next in this pattern? So you need to figure out what they're doing. So these are increasing by adding 1 circle. So I'm going to say we're going to add 1 circle each time. And that is our rule. In order for this pattern to continue, you have to follow that rule. You just would add 1 circle to it. And then our decreasing pattern example, you have a rectangle, 4 circles, rectangle, 3 circles, a rectangle, 2 circles, a rectangle, 1 circle. So you can see how it's starting to disappear, and that's what is causing the decreasing pattern. So for this rule, you would say -1 circle. So you would subtract 1 circle each time, and that would be your rule. Okay, so let's take a look at some examples of number patterns. So a number pattern is a rule that describes the relationship between a set of numbers. The rule can be used to predict the value of unknown numbers in the set. Once you know the rule, then you could plan it out, and you could figure out what comes next for many, many times on. So let's take a look at this first example. Look at the list of numbers below. What is the missing number? So take a look at that. I'm sure you guys are catching on to this. What would come next? So I go 1 to 3 to 5 to 7 to 9. I can see here that I'm adding, this is increasing, right? It's getting bigger. So I'm adding something or multiplying something. I'm actually just adding 2. 1 plus 2 would be 3. 3 plus 2 would be 5. 5 plus 2 is 7. Yep, that's the rule. You want to try it out for a few of them to make sure you are correct. Okay, so 9 plus 2, that tells me that this next number is 11. That was our missing number. Let's look at example 2. Okay, now you can see that the numbers are decreasing. So this is a decreasing, so we're either going to be dividing something or subtracting something. And it goes 90, 80, 70, 60, 50. So you can see that they are subtracting 10 each time. 90 minus 10 is 80. 80 minus 10 is 70. So minus 10 is the rule. So 50 minus 10, the next number in the pattern, is 40. Okay. Example 3. So let's find the missing number. Now this is increasing. The numbers are getting bigger. So we got to figure out how they got from a 2 to a 12. You could say they added 10. Let's try that and see if that works as our rule. Okay, so 2 plus 10 is 12. Let's try that here. 12 plus 10, whoa, 12 plus 10 is not 72. Okay, so that helps us know that we're not using plus 10 as our rule. So let's try multiplying. What would I multiply times 2 to get 12? I would use times 6. 2 times 6 is 12. 12 times 6, let's figure that down here. 12 times 6 is 72. All right, so now we know our rule. So you have to multiply times 6 each time in order to know what comes next. So in order to find this one, we have to multiply 72 times 6. $432. That is increasing very, very rapidly. When you use multiplication, the numbers get very big, very fast. Okay, very good. Now example number 4. What is missing this time? We go from 88 to 44. What did we do? Well, we could try minus 44, 88 minus 44 would equal 44. However, if I continue that idea, right here I should have a 0, 44 minus 44. So that rule is just not going to work. Okay, so we're not going to use this rule. What if we divide something? If I divided 88 by 2, I would get 44. Okay, so this is divided by 2. So let's see if this works here. Divided by 2, would I get 22? 2 divided into 4 is 2. I sure do. I get 22. Okay, so dividing by 2 is my rule. Okay, so then what would come next? I would have to divide 22 by 2. And I would get 11. So that's the next number in this pattern. So number patterns can also be found in tables and graphs, and finding the number pattern in a table can help solve problems. So here's an example of that. It says Jordan is making bookmarks. She is using the same number of beads for each bookmark. So here are the number of bookmarks for one bookmark. She needs 7 beads. For 2 bookmarks, she needs 14 beads. 3 bookmarks, she needs 21 beads. So how many beads would she need for 4 bookmarks? So you got to look at these and try to figure out what is the rule here. There's a couple different ways that you could do this. If you want to look along this side, you could see that you're adding 7 every time. Plus 7, plus 7, plus 7. We would have 28. But if you notice that 1, if you look right here, 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. And 4 times 7 is 28. So either way would work and you'd be able to find this answer.
All right, it's time for you to show what you know about number patterns. Take a look at this one and choose A, B, C, D, or E. What is the missing number in this sequence? Here's another one for you. What is the missing number in this sequence? Choose A, B, C, D, or E. Here's another one for you. It says the table below shows the fees a parking garage charges each car based on the number of hours the car is parked. How much would a customer be charged if parked for 14 hours? So here's our table. If they parked for 5 hours, they're charged $6. If they're parked for 8 hours, they're charged $9. If they're parked there for 11 hours, they're charged $12. What is the pattern? And how much would they charge if they stayed for 14 hours? What is the rule for this sequence? So you can see the pattern here. This time I want you to find what the rule is. What's causing this pattern to grow? Read over these options very carefully, A, B, C, D, or E, and choose which answer you think is correct.
Okay, moving on to geometric patterns. These, you need a good set of eyeballs for these to look carefully at the patterns and the geometric shapes to try to figure out what is different along the pattern. When finding the missing picture in a list of pictures, you need to figure out what pattern exists in the list. First, look at the change in the number of objects in each picture in the list. Then figure out how much bigger or how much smaller each picture is than the picture before. So first of all, let's decide, is this increasing or decreasing? I can just tell by glancing at it that it's getting smaller, right? It's decreasing. This one has a lot more than this and then this, so this one's going to have less. So we're going to be either subtracting or dividing something. So you got to figure out what's different from 1 to 2. It looks like as far as vertically, they're all the same as far as how tall they are. So they all have 6 rows here. So that doesn't change. But you can see the width here, the number of columns is what's changing. So this one has 1, 2, 3, 4, 5, 6 columns. So let's write that down. This one has 1, 2, 3, 4, 5 columns. This one has 4 columns. Okay, so in order to figure out what this one is going to look like, we are subtracting 1 each time, 1 column, but the rows stay the same. So we should have, still should have 6 rows, but we're only going to have 3 columns this time because we're going to subtract one of the columns. So the next picture in our pattern should look something like that. So 1 less column. Okay, so sometimes the pictures increase by a certain amount, or like we've said, sometimes they decrease. So in this picture, in this pattern, you can see that the number of rectangles are increasing by 1. Starts with 1, then goes to 2, then goes to 3. So if they asked you what would the next picture look like, well, you know that it would have 4 rectangles. So sometimes in the SOL questions, they'll give you this part and then give you multiple choice, and you have to figure out which picture comes next. And so here's an example of the shapes decreasing by a certain amount. You can see by just looking at it, this time the number of columns stays the same. They all have 3 columns, don't they? 1, 2, 3. But the number of rows is decreasing. This one has 4 rows. This one only has 3 rows, so this part is missing. And this one only has 2 rows, so 2 of those rows are missing. And so if they asked you what would come next, then you would also just have to delete this row and you end up with just 1 row of circles. So here's an example of a figure or a table, and we're going to fill in the blanks. So in figure number 1, which they have shown here, we're going to figure out how many dots are on the bottom row. So 1, 2, 3 dots are on the bottom row. So they made a little pyramid here. And the pyramid keeps getting bigger and bigger. So this is increasing in the pattern. So figure 1, there's 3 dots on the bottom. Figure 2, there's 4 dots on the bottom. Figure 3, there's 5 dots on the bottom. Okay, are you seeing a pattern? Something that we're either adding or multiplying since it's getting bigger. You can see here for the first figure, if you add 2 to that number, then you get 3. Same is true for this. If you have the second figure and you add 2, you're going to have 4 dots on the bottom. For the third figure, if you add 2, you're going to have 5. So for the fourth figure that we can't see, we know it's going to have 6 little dots on the bottom row. So if we lined them all up and all of a sudden we have 9 figures, I don't even have to draw it to know that I'm just going to add 2. I'm just going to follow this pattern. So the 9th figure all in a row, I would have 11. 10, the 10th figure, I would have 12. And the 11th figure, I would have 13. So let's say we draw this 50 times. 50 times, and every time we've gotten bigger and bigger and bigger. So now I have figure number 50. How many dots would be on the bottom row? You just keep that same pattern. You add 2. So the 50th figure would have 52 dots at the bottom. So once you know the pattern, boy, is it easy to come up with the rest of the numbers in the table. Okay, so how can you find the total number of dots in the bottom row of any figure if this pattern continues? So it just gives you a little formula that you could put in. So whatever this is, if you add 2 to it, that would be the total dots in the bottom row, which is what we did. So n is just like a substitute for a number. So if n equaled 100, then we would say 100 plus 2 down here. So that's how you do that. So you want to make sure you're really good at finding what the rule is of the pattern that they're showing you. Okay, here's another example. The first figure has 3 squares. Okay. Second figure, we don't know. Okay, you can see here it says in the pattern above, what will the diagram in position 2 look like? So this is what we're trying to figure out. What should go here? Whoa, now this increased quite a bit. So this one has, how about we write this down? This one has 1 row and 3 columns. Columns, sorry. Okay, so we don't know anything about 2 yet, but for number 3, it has 3 rows, and it has 9 columns. Okay, and number 4 has 4 rows. Oh, I see one pattern there. And then it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. Okay, so let's take a look at what we have. It looks like the rows are increasing by 1. Okay, so I think this one is just going to have 2 rows. How many columns will it have? It goes from 3 to we don't know, to 9 to 12. So the difference between 9 and 12 is 3. So do you think that would work if we made the rule plus 3 for the columns? Let's try it. So if this one was 3 columns and we added plus 3, we would have 6 columns. Okay, and then if we added 3 again, we would get 9, so that works. Okay, so I think this is right. I think for number 2, it's going to have 2 rows and 6 columns, which is, right here. Look at that. 2 rows, 1, 2, and 6 columns. 1, 2, 3, 4, 5, 6. Okay, so B is correct. See how I took some time with that? I didn't just glance at it and take a guess. I really tried to figure it out, and that's what I want you guys to do too.
Okay, it's time to show what you know about geometric patterns. So look at the pattern above. What will the diagram in position 4 look like? Look carefully at the object in position 1, 2, 3. How is it changing? And what will it look like in position 4? Okay, last question. Listen carefully. Here is our pattern. We can see what it is in position 1, 2, 3, 4. Look carefully to how it's changing. In the pattern above, if the pattern continued, how many more blue circles than red circles will there be in diagram 6? Think about it and then choose your answer. All right, friends, we're finished with math video number 21. Don't close the video until you click on the smiley face and let me know what you think of patterns. There is a Study Island lesson that goes along with this video, and you can get more practice by going to IXL.com. Always remember to forget the mistake, but remember the lesson. There's going to be lots of times when you're doing math and you make a mistake, but what's important is that you think about, what did I do wrong? So then you can learn from it and remember that lesson when going into the next problem. All right, friends, I hope you have a wonderful day. Bye-bye.